Today, we're talking about a truly mind-bending breakthrough in quantum mechanics that could accelerate the entire field of quantum computing. Scientists have essentially built a quantum lie detector, a new method to prove that incredibly complex quantum computers we're building are the real deal and not just clever fakes. This is a fundamental step that builds confidence and paves the way for the next generation of quantum technology. So basically, they tell the difference to whether this is a device is acting at a quantum level or it's just acting at a traditional computing level, mimicking quantum.
Yeah, this is cool. So you and I have always talked about this when, like, how do we know it's actually quantum? How do we know that this isn't, that they're not faking it? So here's the thing, right? Put yourself in the shoes. Imagine you bought what claims to be a quantum computer, right? How are you going to prove that it's actually using real quantum effects and not just pretending, like you and I have talked about? So scientists from a bunch of universities have developed what they call the quantum lie detector. So using a 73-bit qubit superconducting quantum processor. So think of qubits as quantum bits, which are the building blocks of quantum computers. So they applied Bell's test, who did a famous physics experiment in the 1960s. And what they saw was kind of cool. So they measured energy levels 48 standard deviations below what any classical system could achieve. So to put that into perspective, that's virtually impossible to occur by chance. So it's like flipping a coin and getting heads 48 times in a row multiplied by itself. So what actually makes this groundbreaking is the scale at what this test is. So previous tests worked on small systems, but this test proved that large quantum system up to 73 qubits truly exhibit quantum non-locality, which is the spooky action at a distance. It's that Einstein famously disliked, right? So this matters because it ensures quantum computers aren't just getting bigger. They're actually staying genuinely quantum, which is crucial for future applications in secure communication, cryptography, and other quantum algorithms. What are your thoughts on this, Craig? Do you think that this is helping to validate quantum computing, or do you think this is just another test that we're still kind of skeptical?
Well, I hope it validates it. I'm a little skeptical because we're just getting the information, but I'm sure with some demonstrated reusability of this thing where it's repeatable, repeatability of it, doing the scientific method, that we can discover, yes, this is good. That'd be great. And the Bell's test is the famous test for testing for quantum behavior created by physicist John Bell in the 1960s. The test can tell the difference between quantum and classical systems. So being able to wire this up in a quantum 73 qubit kind of way is very interesting. So they've nicknamed it. Go ahead.
No, keep going.
They've nicknamed it the quantum lie detector. And as you mentioned, it's important because as quantum computers get bigger with more qubits, it becomes exponentially harder to prove they're genuinely quantum. This breakthrough provides an efficient way to test them. So that as we grow, are they actually just computing, or are they doing beyond computing? Are they using the full range of the qubits, or are they just doing ones and zeros? Are they, pulling the quantum universe across multiverses, or is it just sitting here doing nothing? Based on all this stuff, this is supposed to test and verify for that. So I think it's important because we've seen so many fakes in the world that you scratch the surface and it's not there. Things like
there's still that Google chip, or was it Amazon chip?
It was the Microsoft topological chip.
Yeah,
I believe, with the topological bits that were the problem. We've covered a lot of this, so it depends on which one we're talking about. But yeah, and but just like Theranos and all the AI-based stuff that's just ChatGPT on the back end, or it's good to be able to find out is this truly what they say it is, or is this something else?
Yeah. So I don't know if you talked about the previous test, but they typically involve fewer than 10 qubits. And like you said, scaling that up makes things not just harder. Like you said, it's exponentially harder, which means every single qubit just makes things to the power of X harder, right? So that's a significant milestone in demonstrating that large-scale quantum processors actually exhibit authentic quantum correlations. So the energy-based approach, it's kind of clever because minimizing energy is something that quantum systems do naturally through variational algorithms. And so this makes the test practically implementable on current quantum hardware without requiring exotic measurement schemes, which is kind of cool. So the Bell correlations, they actually provide a more stringent benchmark than entanglement alone, which is kind of interesting. So a system can be entangled without violating Bell inequalities, but violating Bell inequalities proves the presence of quantum non-locality, which is the strongest form of quantum correlation. So this gives hardware developers and users confidence in device performance, which I really like.
Same. And as they expand and grow, to know that we're using beyond the 24 qubit, beyond the 50 qubit, beyond the whatever, that you'll be able to detect these things and say that it's actually using it, that you get to a certain point and it doesn't just scale down and just do normal processing. So as they expand, as they test new systems, I'm really excited that we've got a new way to test this, and that it tests that it's actually, for lack of a better word, being spooky at a distance.
Yeah, what I like about this is it's not just science fiction, it's not just theoretical, it's actually happening now in laboratories in China, in Europe, and worldwide. And where I see right now, we're in the early days of quantum technology revolution. Just like classical computing, when it went from room-sized machines to pocket smartphones, this quantum technology, I feel, is evolving more rapidly, but I could be wrong. But studies like this are going to ensure that we're building on solid quantum foundations, not illusions. So I love this I love this experiment.
Yeah, I'm really excited where this goes, and the fact that there was a huge, massive difference of 48 standard deviations separated quantum from classical results means even if it gets closer, there's still a huge deviation that we should be able to continue to tell for quite some time. So the future looks bright as far as multifunction on quantum processing goes.
Yeah, for sure.
So what we're seeing is a bedrock of future quantum technology being solidified. This lie detector isn't a product you'll buy, but it's an impact that will be felt in the speed and reliability of quantum advancements for years to come. It answers a critical question. As we build bigger, do these machines stay truly quantum? The answer, for the first time on a large scale, is a resounding yes. It makes you wonder, what seemingly impossible problems will this new confidence help us solve next? Let us know what your thoughts are. So what do you got going on, John?
Yeah, well, just helping companies secure government funding. So, it's a great time to reach out if you have any questions. How about you, Craig?
Well, there's a lot going on over at flowgrammer.ca. We're doing automation and AI and business processes. We do events, but we're really ramping our business up. And check out all the things we're doing over there. If you're interested in business automation, we've got community events where we're teaching everyone. We do an online, and we're about to launch our new resource center, flowgrammers.ca, which might be out when some of these are out. Other than that, check out for everything we do. Our monthly startup investor drinks, where you get to pitch to the crowd, business owners and investors, and have real conversations and make real connections. So for all those things, check out TorontoStarts.com. And for everything else, anything else, John, before we say goodbye?
No, just reach out to me on LinkedIn, John Irwin, if you want.
John Irwin on LinkedIn. Thanks, everyone. We'll talk to you soon.